Here we go with scientific notation. Alright, scientific notation is a way of writing numbers that are too big or too small to be written in standard decimal format. So here we see a very large number, and here we see a very small number. It can get exhausting writing all of those zeros, so each of these numbers are better written in scientific notation. So we'll take a look at exactly what makes up a number in scientific notation. It's made of two parts, the significand and the exponent. When you have a number like 7.3 times 10 to the fifth, the significand is that 7.3. When we start talking about significant figures and we have numbers that are written in scientific notation, the significand is going to be the only part that is significant. So it should be pretty easy to remember. The other part of our number is the exponent. All this does is let us know how large or how small our number is, but it does not figure into how many significant figures are represented in our measurement. So in order to write large numbers in scientific notation, like the one we saw before, we have to know that there is an understood decimal right here. Okay? Sometimes it will be written, sometimes it's just understood. In order to write this number in scientific notation, the decimal needs to be moved between the first and second non-zero digit. You cannot start a scientific notation number with a 0 point. You have to have a number before that decimal. So with our large number, our decimal is going to be moved right there. Okay, then we count how many times we move the decimal. In our case, we moved it 13 times. Because we moved it to the left, our exponent gets larger, giving us the number 9.45 times 10 to the 13th. So remember, left, larger, left, larger. Move the decimal to the left, your exponent gets larger. Writing small numbers in scientific notation is very similar. Here we've got our small number from before. In order to write this number in scientific notation, the decimal needs to be moved between the first and second non-zero digit. Again, you cannot start a scientific notation number with a 0. Your significand must have a non-zero digit in front of the decimal, and only one. So we take this very small number and we move our decimal right there. Okay, again, we count how many times we move the decimal. Again, in our case, it is 13 times. And now, because we moved it to the right, our exponent gets reduced. So we get a negative exponent since we had an exponent of 0 to begin with. So we get 3.8 times 10 to the negative 13th. So left, larger, right, reduced. Left, larger, right, reduced. Alright, adding and subtracting. Unfortunately, there's not a shortcut. Of course, you can plug it into your calculator. That's going to be the easiest thing to do. But if you don't have one, you can expand each number, perform the calculation, and then condense the number back down to give your answer in scientific notation. So, for example, if we wanted to add 3.45 times 10 to the fourth plus 1.90 times 10 to the third, we can expand those numbers out, get 34,500 plus 1,900. Add those up, you get 35,400. We can then move our decimal to the left, so we get a large exponent, and we end up with 3.54 times 10 to the fourth. Same goes for subtraction. Now, multiplying and dividing, we have shortcuts. When multiplying numbers in scientific notation, you can perform the calculation with the significand, so you can multiply your two significands, and then you add your exponents. The last step, you just have to make sure to adjust your final answer to reflect correct scientific notation. Remember, that means that your decimal is between the first and second non-zero digit. Not at the very front, not at the very end, but between that first and second non-zero digit. So our example here, we've got 9.8 times 10 to the fourth times 2.8 times 10 to the ninth. So I can take that 9.8 and that 2 times 8 and multiply that, and then multiply the whole thing by 10 with the exponent being equal to 4 plus 9. So that's going to give me 27.44 times 10 to the 13th. But you'll notice our decimal is between the second and third non-zero digit, so we've got to move it one time to the left. What happens to your exponent when you move it to the left? It gets larger. Now we're going to have 2.744 times 10 to the 14th. Because we moved our decimal to the left, our exponent is larger. Okay, with division, again, you can perform the calculation with the significand, but now we subtract the exponents. And lastly, we make sure to adjust our final answer to reflect scientific notation. So now we have 3.2 times 10 to the second divided by 5.4 times 10 to the fourth. Okay, so we can take 3.2, divide it by 5.4, and then that answer is going to be multiplied by 10 to the 2 minus 4 as our exponent. So we get 0.59 times 10 to the negative second. Now again, notice our decimal is not in the correct place. It is before the first non-zero digit, leaving us a 0 placeholder in front of us. So we're going to have to move our exponent one time to the right. And what happens to our exponent when it gets moved to the right? It gets reduced. So we end up with 5.9 times 10 to the negative third. Remember, because you moved your decimal to the right, your exponent is reduced.